Here's pre-calc. It's problem 5-24. It says solve for x. So it starts out just with this one. And so these are rational, it's a rational function. So it's going to have asymptotes, and the easiest way, it's an inequality. So there's going to be like regions where it's going to have these regions where there's our solution. So we're going to subtract 2 on both sides. And then we're going to go ahead and, you know, like on inequalities, how it's not just like x equals blah. There's going to be like an interval. Like there's going to be an area that makes this inequality true. Like that's why we shade these. So we're trying to find these split points, these boundary points, that kind of is going to break this up into regions on the graph, so we can see where it is, where the solution regions are. Or in this case, since we've got it so that now we've got everything on the left-hand side we've got just 0 on the right, everywhere on the graph where this function is positive, because greater than 0 is positive, is going to be a solution. So we're trying to find that. So the easiest way to do that is to get this all nice and factored so that we can like start finding our split points. So let's get a common denominator. That would be the first thing to do. So a common denominator, this is over 1, would be x times x plus 2. Okay, so for this to have an x times x plus 2, I need to multiply the top and bottom by x. So 1 times x is x. So I'm going to kind of just write it all across here. This one I would need to multiply the top and bottom by x plus 2. So I'm going to have minus x plus 2 came from this fraction here. And in this one, I have to multiply that negative 2 by x times x plus 2. So that's going to be, oh, I went a little crazy with the parentheses. So let's make this look a little nicer. Okay, I'm going to distribute, and we'll have, I think these x's are going to go away. X minus x is going to be nothing. And then x times, well, I'll go ahead and distribute it out so I don't make a mistake. Hopefully I didn't make any mistakes yet. And then I've got x minus x is nothing. Okay, so let's factor out a negative 2 here. And I got x squared plus 2x plus 1, I think. Okay, we're getting it all nice and factored so that we can find our split points. Because it's a rational function, and I don't know if you guys remember about the rational functions, but we know that they have asymptotes wherever we get 0 denominators. And then also they'll have intercepts, x-intercepts. Well, we got to factor this first, but that's going to help us find the x-intercepts. So this factor, I think this factors really nicely. It just goes, well, isn't it x plus 1? 1 times 1 is 1. I think this is going to be like this. And it's a rational function. I could even graph it if I wanted to. I'm probably not going to, but it's going to have some asymptotes where x is 0, because that would zero out my denominator. And when x is -2, that's going to zero out my denominator. It's going to give it those vertical asymptotes, but it's also going to cross the x-axis at when x is -1. And I am going to actually show you a graph of what this looks like, because I graphed it on Desmos, so you can get a better idea of why these are split points. So basically, you grab your split points. I call them split points. And this is where the graph is going to probably change from positive to negative. And we're looking for the places where the graph is positive as being solutions. So I'll usually just make a little number line. And I'll put my split points on it. And then I'll think about numbers that are like, so there's these regions here, making squiggly lines. There's these regions. So the region to the left of -2, I can plug something in that's to the left of -2, like -3. If I plug -3 in everywhere, well, this thing, this factor, no matter if I plug negative or positive in it, I'm still going to have positive because it's getting squared. So I'm going to have a positive in here times this -2. So the numerators, I'll just make a little chart for myself. The numerator is going to be negative if I plug in -3. And the denominator is, I think, also going to be negative, I'm going to have a negative times -3 plus 2, that's negative. I'm going to have a positive. So if I plug in -3 everywhere, I will have a negative fraction, which does not make this inequality true. So I'm going to write false. Put it at, that's not part of the solution area. Now let's look in between -2 and -2 and -1. A number between -2 and -1, I guess we have to go with -1.5. So -1.5, I already know it's going to make this part, we're going to have the negative numerator. -1.5 is going to make this inside here positive. And then this, when I plug it in here, though, it's going to be negative. So I'll have a positive times a negative, which is a negative. So that means my fraction will be a negative over a negative. So this is actually going to be positive. And I'm going to write, I don't know, true, T for true. So in between -2 and -1, that region is a solution. Now let's try something in between. This was -1 and 0, remember? So I guess it has to be -0.5. So -0.5, plug it in here. It doesn't matter what I plug in here because it's going to multiply with negative. It's going to be positive, and then it multiplies with -2. So I'm going to have a negative numerator. -0.5, plug it here. That makes this little piece negative. Makes this little piece positive. So I'm going to have a negative over a negative. Negative divided by negative is positive. So I think we're going to also have, this is also a solution. Okay, so, and then let's see, this is 0. So anything to the right of 0, like some positive number I can plug in, like 1. So let's plug in 1. Well, again, this little piece is, no matter what I plug in here, it's going to be positive times a negative. So I'm going to have a negative numerator of my fraction. I plug in 1 here. This whole thing, that'll be positive times a positive, positive. So I'm going to have a negative over a positive. That's negative, which does not make this true. So this will be false. So I know that my solution region is like this. X. Oh, and let's use our favorite notation, our interval notation. Can I say it's -2 to 0? Oh, wait, but it can't. So I was going to say it was between -2 and 0, but then I remember it can't be -1 because -1 is not a solution. So it's going to be, we're going to have a union. So it's going to be between -2 and -1, and I have to union that with -1 and 0. See, I would have just written it just like this, except for that it's not allowed to be -1. So, sorry, it's a little bit tricky, but this is my notation. This is my solution region, and I'm going to show you a picture of the graph because I have it on Desmos. So this is what the graph looks like. So I think let's do this. Let's go. So they do, it looks like they have the whole region between -2 and 0 on here. Your answer key's got it. Oh, your answer key has a note. It says, when x is -1, the final rewritten expression becomes 0 greater than 0. Hence, x equals -1 is not part of the solution region. So that's another reason why we can't have our split point be part of our solution region. So even though I want to just write it as -2, 0, we can't have -1 as part of the solution region. Because why? I just read why, and I need to understand it better. Because when x equals -1, the final rewritten expression becomes, the final rewritten expression becomes 0 is greater than 0. That's not true, though. 0 is not greater than 0. So let's try to understand what they just said. So 1, okay, if this is -1, then I get 1 over 1. Let me rewrite that over here. So when you plug it back into the original, I think there's going to be a problem. And then minus 1 over -1 greater than 2. Okay, so that gives me 1 plus 1 greater than 2, 2 greater than 2. So whichever way you plug it in, the -1 doesn't work back in the it's not a solution. If this would have had a little equal then symbol on it, then it would have worked. So this is the answer.